So in the previous video, we talked about relations, and those were just a set of ordered pairs, and there was different ways you could represent those. So in this video, we're going to talk about functions, which are actually just a special type of relation. So a function is a relation in which each element of the domain is paired with exactly one element of the range. So that means each x value, or domain, is paired with exactly one y value. Now, that means I could have something like 2, 3, 4, 5, and 6, 7. Because each of my x values only have one y value. 2 goes with 3, 4 with 5, and 6 with 7. So this one is a function. However, if I had something like 2, 3, 2, 4, and 6, 7, that would not be a function because the domain value of 2 goes to 3, and the domain value of 2 goes to 4. So that's not allowed for it to be a function. It's still a relation, but it's not a function because that domain value repeats and goes to 2 different y values. Now, it doesn't matter what the y values are doing. So if I have all different x's, but all of my y's are 4, that's okay because 1 only goes to 4, 2 only goes to 4, and 3 only goes to 4. If I added a number like 3, 5, then it would not be a function because the 3 goes to both the 4 and the 5. So keep that in mind. So in this page, we're going to determine whether each relation is a function and explain. So go ahead and pause the video here and try these out. Okay, so example 1, this is a function. Each x goes to only one y. So -2 only goes to -3, 0 only goes to 6, 3 only goes to 6, and 4 only goes to 9. So if the way this could be not a function is, for example, if 4 also went up to -3. Then I have 4, my domain value, going to 2 range values, and then that would be not a function. Example 2, this is not a function because my domain value of 1 goes to 4 and -4. So 1 goes to 4 and -4. And same with example 3. This is not a function. And this actually happens twice. 2 goes to 1 and -2. Okay. And 3 goes to 1 and -2 as well. So the domain values go to 2 range values. Now sometimes we have a graph, and that has an infinite amount of points on it. So there's another test we can use to see if something is a function. This is called the vertical line test. The vertical line intersects the graph more than once. So remember, vertical is up and down. Then the graph is not a function. And that would be because if I'm intersecting 2 points, for example, let's say this is my x-axis and y-axis. Those 2 points, say 1, 2, 3, would be like 3, 1, and 3, let's say -2. They have the same x value of the vertical line as intersecting them at the same time, and so that goes back to our ordered pairs. If the x values are the same, then it's not a function. So to determine whether each relation down here is a function, so go ahead and pause the video and see if you can get them. So this first picture, this is a function. So if I was to draw vertical lines through here, I'm only intersecting one spot on the graph at a time. Okay. The second one is not a function. if I was to draw a vertical line, say here, I intersect the graph at this point and this point down here. So there's 2 points that are intersected on that vertical line. Now this third one is a little tricky. It actually is a function. Now if you said it wasn't because of this point here, where it looks like it intersects 2 spots, it actually isn't intersecting 2 spots because this one up here is open, which means that that point's not actually there. It's just where the line is starting, and then it's closed down here. And so it's only intersecting the graph at the bottom point. The top one is not an existent point. So just be careful with those. The other thing about functions is we often use function notation. So functions are usually indicated by the symbol f of x, and that's read as f of x. Other letters such as g or h can also be used and are used quite frequently. So example, for f of x equaling negative 4x plus 7, find the values below. So we're going to use this function here, and they want us to substitute 2 in to the function. So f of 2, they want us to substitute 2 in for all of the x parts. So now this is not f times 2, this is f of 2. So we're not going to change this left side at all. The right side though, you have negative 4 times 2 is negative 8, plus 7 is negative 1. So f of 2 equals negative 1. And you can read that as when 2 is substituted in for x, I get negative 1 for y. So f of x is kind of like y actually. So we would know if we were to graph this, that this order pair 2, negative 1 would actually be on my line. So f of 2, so when x is 2, we get negative 1. Alright, so this next one says f of negative 3 plus 1. So we're still going to put negative 3 in. But because they also tell me to add 1 to this, I need to put a plus 1 at the end over here. So f of negative 3 plus 1 okay, and I'm actually going to leave these as f of x, just so you're not as confused. So I'm doing negative 4 times negative 3 is 12, plus 7 plus 1. So 12 plus 7 is 19, plus 1 is 20. So when I actually plug in negative 3 for x and add 1, I get 20 as my answer. And so the next one says f of negative 1 plus f of 2. So that means I'm doing 2 things. I'm putting negative 1 in, okay, to the function, and then I'm also putting 2 into the function, and I'm going to add those 2 parts together. So in this first one, I get 8 plus 7, so that's 15, and I get negative 8 plus 7 in this next one, which we know is negative 1. So I get 15 plus negative 1 is 14. So when I put negative 1 in and 2 in and add those 2 answers, I get 14. And that's all there is for function notation.